Assalamu alaikum everyone. क्या हाल है आप लोगों के? This stream is going to be um, an hour and a half max. Hour and a half some job to be on the safe side. Okay, so let's start. So I will be solving past paper questions. I have already uploaded the concept videos. I would like you guys to check it out if you haven't done that yet. Please don't expect me to teach the entire topic from scratch. That's practically impossible. So we're going to start off with some easy questions and then gradually increase the difficulty level. And by the way, you guys can download this PDF. You'll find a link to it in the description, inshallah. So let's start. Now, before I start officially, I would appreciate if you guys like the stream and subscribe to the channel if you haven't done that yet already. Okay, so like I said, we'll start off with some easy questions. My goal is to solve at least around 10-12 questions, and maybe if there's a part 2 needed, we'll do a part 2 also. Okay, so let's start with maybe question number 2. Let's see what question 2 says. So question 2 says a lorry of mass 16,000 kg is traveling along a straight horizontal road. So make sure to underline the word horizontal so that you don't have to break down forces into different components. The engine of the lorry is working at a constant power. The work done by the driving force in 10 seconds is 750,000 joules. Find the power of the lorry's engine. Now there are two ways that we calculate power. One is that power is equals to force multiplied by velocity, and when we talk about force, we're talking about the driving force, obviously. Okay, or power is equals to work done upon time. Now, the first formula we use if, let's say, we want to calculate power at a certain instant and we're given the velocity at that instant, or maybe the engine is traveling at a constant speed, or the car is traveling at a constant speed or constant velocity. But because that's not the case here, we're not going to use this formula. Here, we're going to use this formula because we're given the work done and we're given the time. Now, what's the work done? The work done is 750,000. What's the time? That's equal to 10 seconds. Make sure to read the question carefully. Sometimes the question will ask you to give the answer in kilowatt, but that's not the case over here, so we're fine. So 75,000 watt is the answer to this part. That's it, one easy mark. Okay, so this is an overall easy question, and I've decided to solve some easy questions first. Next, the question says that there is a constant resistance force acting on the lorry of magnitude 2400 newtons. Find the acceleration of the lorry at the instant when its speed is 25 meters per second. So remember that there are two formulas for power. Power is equals to force into velocity. And when we say force, we mean the driving force. Now, if you think about it, we've just worked out the power, okay? And we're also given the velocity. So that means with the help of these two pieces of information, we can calculate the driving force. What's the power equal to? The power is equals to 75,000. And what's the driving force? We don't know what the driving force is. We do need that. Into the velocity, we know that's 25. So now we can calculate the driving force, which is equal to, let's work this out, see what do we get, 75,000 divided by 25. So that's equal to 3,000. So the driving force is equals to 3,000. Now, before I can calculate the acceleration, the formula that we have to use is F net is equals to mass times acceleration. Now, what's F net? F net is basically all the forces acting in the direction the object is moving minus all the forces acting in the opposite direction, which is equal to mass into acceleration. Now, there's only one forward force, which is the driving force. Okay, and there's only one backward force, which is the resistance force. and that's equal to mass times acceleration. So that means 3000 minus 2400 is equals to mass times acceleration. What's the mass? The mass is 16,000. What's the acceleration? We don't know. So this will be equal to 600 upon 16,000. That's the value of A. So let's work this out. 600 divided by 16,000. That's equal to 3 upon 80 or 0.0375. So 3 upon 80 is good enough. If you want, you can write it in decimal also. 0.0375 meter per second square. There you go. Okay, so like I said, fairly easy question. We're obviously going to do difficult ones as well, but I want to start off with some easy questions so that we learn the formulas that we have. Okay, let's use this question. Let's see what this says. A minibus of mass 4000 kg is traveling along a straight horizontal road once again. So when the road is horizontal, that's when you know that the question is going to be fairly easy one. The resistance to motion is 900 newtons, and when there's only one object, when you have multiple objects and the road is inclined, that is when things get difficult. Find the driving force when the acceleration of the minibus is 0.5 meter per second square. Okay, so remember F net is equals to mass times acceleration, and what's F net? That's all the forces acting in the direction the object is moving minus all the forces acting in the opposite direction is equal to mass times acceleration. Now let's see what is the driving force. We don't know that. What's the resistive force? We know that's equal to 900. And what is the mass? That's equal to 4000. What's the acceleration? The acceleration is equal to 0.5. Okay, I'll increase the volume a little. There you go. Should be fine now. Let me know if it helps. So the driving force is equal to 4000 into 0.5, that's 2000. 2000 plus 900, that's 2900. Okay, I will advise you to use a calculator, but if you're feeling very confident, you can do it without a calculator as well. Okay, now find the power required for the bus to maintain a constant speed of 25 meters per second. So now we can use this formula. Power is equals to driving force multiplied by velocity. So what's the power required? We don't know. The driving force. Okay, now just a minute. The driving force will not be the same as this one, because if it's traveling at a constant speed, that means acceleration is equal to 0. Okay, so, and acceleration equals to 0 means that F net equals to mass times acceleration. Now what's the driving force and what's the resistance for, what's the resistive force? That's equal to 900. So driving force minus the resistive force equals to 0. That means the force that's needed, first of all, that's going to be equal to 900. You don't need this force because this force ends up in what? This force ends up in the object accelerating. In order to make sure that the object is traveling at a constant speed, the driving force must be equal to the resistive force. Okay, and now we can work out the power. Power is equals to driving force into velocity. What's the velocity? The velocity is 25. So what's the power going to be equal to? The power will be equal to 22,500 watt. Make sure to read the question carefully. Sometimes the question will ask in kilowatt. We're not supposed to do that here, so this is good enough. Hello. Now let's do a slightly more complex question. Kya khayal hai? Let me find a slightly more complex question. Let's do that. Channel lucky you. Walaikum assalam. So there was this question where we had an inclined plane. I'll do questions like these also, but we'll do them in a while. First, let's do some slightly easy questions. So I'd like to solve this question. Question number 40. So in M1, last questions are horror. Yeah, last questions are usually work energy power, so those are kind of scary. Yes, Fatma, we're doing those questions now. Okay, it's just that I want to gradually increase the difficulty level, not straight up take you to a difficult question. Okay, so let's solve this. Let's see what this says. A block of mass 10 kg is at rest on a rough plane inclined at an angle of 30 degrees to the horizontal. So do keep in mind that this is a rough plane. a force of 120 newtons applied to the block at an angle of 20 degrees above the line of greatest slope. There is a force resisting the motion of the block, and 200 joules is the work done against this force when the block has moved a distance of 5 meters up the plane from rest. Find the speed of the block when it has moved a distance of 5 meters up the plane from rest. Okay, now, so remember the work energy formula. What's the work energy formula? The work energy formula is total work done is equals to change in potential energy minus change in kinetic energy. Okay, so let's work that out. Total work done is equal to change in potential energy plus change in kinetic energy. Okay, I'll be watching the stream after I'm done with M1. Okay, so then good luck to you. Now, what do we mean by total work done? Remember, total work done basically means by minus against. Okay, meaning by the driving force, and against means against the, basically could be against friction, work done against friction, which we're already given, by the way. Okay, which we're already given is 200 joules. Okay, so we're going to use that also. Okay, now let's see what's next. Change in potential energy. Now, because the block has moved a distance up the plane, so we need to consider that. Okay, and let's see what will be the change in potential energy. So if a block, so that's an unnecessarily long triangle, let's make a small one. So if a block moves 5 meters up the plane and this is 30 degrees, then what would be the change in height? The change in height would be 5 sine 30. Okay, so keep that in mind that the change in height would be 5 sine 30. I keep forgetting these formulas. Well, you have to memorize these formulas. There is no other way, I'm afraid. You have to memorize these formulas. Okay, now what else? What else can we consider? Now, as far as the work done by the driving force is concerned, remember, because the object is moving in this direction, that means we have to consider the force in this direction as well. What would be the force in this direction? The force in this direction would be 120 cos 20. Okay, so remember, when we're calculating work done, which is equal to force time distance, so force and the distance must be in the same direction. So because the object is moving in this direction, we have to take the force, we have to take this component of the force as well. Screen not clear? I don't know if that's the case with everyone. I think that's just the case with you. Anyway, so we have all we need. Work done by, that means by the driving force. What's the work done by the driving force? That would be 120 cos 20 multiplied by the distance, which is equal to 5. Now, the question has given us that what is the work done against friction, or what is the force resisting motion, and what's the work done by that force? That's equal to 200 joules. Okay, so this is what we subtract. And then this will be equal to, now this is not for O-level, Peter, read the title. This will be equal to change in potential energy. Now, change in potential energy would be a gain because the object has moved up the plane, and we have to find out the speed. So it starts from rest. That means it definitely gains some kinetic energy. So this would be equal to mass, which is equal to 10 into g, which is also equal to 10, multiplied by the height, which is equal to 5 sine 30. So if the object from here moves here, that means the change in height is equals to 5 sine 30, and this is the gain in potential energy. We'll put a plus sign because there is gain. We'll look into those scenarios also. Plus the change in kinetic energy. Now, how would you calculate the change in kinetic energy? That's simple. Half into mass, which is equal to 10 into v square minus u squared. And what's the initial velocity? It's 0. Why? Because it was initially at rest. So might as well ignore this minus 0 square and just keep it as 1 upon 2 times 10 times v squared. That's it. So I'll explain this formula again. This formula is a golden formula which will solve all your work energy related problems. So total work done means work done by the driving force, or any force any external force that's acting in the direction the object is moving. Okay. Against means any force that's resisting the motion, which could be resistive force, which could be friction. So we need to consider the work done by that, and that is already given to us, so we don't need to do that ourselves. Is equals to change in potential energy. So if the object is going up, it's going to be plus. If the object is going down, it's going to be minus, and equals plus change in kinetic energy. So if the object is speeding up, it's going to be positive, and if the object is slowing down, it's going to be negative. But you don't have to worry about it. That the formula will take care of itself. Okay, so let's work this out. 120 cos 20 multiplied by 5, that's equal to 563.8155. Since it's not the final answer, we're not rounding it off. Minus 200 is equals to, let's see what do we get, 10 times 10 times 5 sine 30, that's equal to 250. 250 plus 5 v square. So let's make v square the subject. So 563.8155 minus 200 minus 250. So 5v square is equal to 113.8155. Let's divide it by 5. So v square is equals to 22.7631. And then finally, let's take the square root of the answer. So we have 4.77, and that's the answer. 4.77 meters per second. And there you go, job done. Now this was, like I said, a slightly more complex question, not a very difficult question, but we're about to solve those difficult ones now. Achha, what's that? No, in M1, you use acceleration due to gravity as 10. Okay, you don't use as 9.81. I think that's what you use in physics. In M1, you use 10. Okay, so let's solve one of those questions where you have an inclined plane. Yeah, let's do that. So we'll solve this question also. First, let's do where you have two objects, and yeah, let's do this question. So let's see what this says. You made it look easy, so I'm glad. But don't worry, we were solving easy questions. Now we're going to solve some difficult questions, okay? So a car of mass 1500 kg is pulling a trailer of mass 750 kg up a trailer of length 800 meters, okay? Inclined at an angle of sine inverse of 0.08. So don't freak out when you see something like this. Just remember theta is equals to sine inverse of 0.08, which means sine theta, which is something that you're likely to use, is equals to 0.08. And make sure that you mention this, okay? Because in the examiner report, you'll find that they have asked to show this working. Okay, now, the resistance to the motion of the car and the trailer are 400 Newton and 200 Newton respectively. The car and the trailer are connected by a light, rigid tow bar. The car and trailer have speeds 30 meters per second at the bottom of the hill and 20 meters per second at the top of the hill. Use an energy method to find the constant driving force as the car and trailer travel up the hill. Okay, now what does it mean when it says use the energy method? This is what it means. Total work done is equals to change in potential energy plus change in kinetic energy. Okay? Now, remember, total work done means work done by the driving force minus work done against resistance. Okay? Now, a good idea would be, as always, is to make a rough sketch. Okay, you'll find this in the examiner report. You'll find this in multiple places that they say that candidates who make a rough sketch are able to solve the question better. Okay, maybe one of these days I'll post some screenshots from the examiner report to give you guys some key insights from it. Okay, now I like to draw them as circular objects. It's kind of easy that way. So here's a car and here's a trailer, and they are connected by a light, rigid tow bar, as the question says. Okay, now the force that's acting on the trailer, the resistive force, that's 200 newtons, and the resistance force that's acting on the car, that's 400 newton. Okay, so keep that in mind. Now, what about the change in height? Sir, Captain, Doctor, कुछ जवाब दे दें. Please tell if finding inverse. It's not in the O-level math syllabus. So this is theta, and this is the height. Now for height, I always prefer that you make a separate triangle. Now they travel up the hill. Are we given the length of the hill? I think we are. Yeah, 800 meters. Okay, so 800 meters is the length of the hill. This is theta, so that means the height, the change in height would be equal to 800 sine theta. Okay, what's that, sir? I'm a bit late, but in the previous question, why didn't we include? Because when you, okay, that is already taken into consideration when we do change in potential energy. Okay, so any external force that we have, any external resistive force, that's the one that's taken, not its own weight component, because its own weight component is taken into account when you do change in potential energy. Okay, but I've already answered that question. I think your objective is to just spam, so I'm afraid I'm going to have to take measures accordingly. Anyway, so here we are. Now let's see if we are in a position to use the formula. Yes, I think we are. So work done by the driving force. Do we have the driving force? No, we don't. Okay. Let's see what the driving force is. We'll just call it driving force multiplied by the distance. Because remember, work done by any force is equals to force times distance. Minus, now what is the combined resistive force? That's equal to 200 plus 400. That's equal to 600. So 600 multiplied by the distance, which is equal to 800. And if you're wondering where the 600 came from, this 600 is basically 200 plus 400. Okay, equals to change in potential energy. Now how would you calculate change in potential energy? That would be mgh. Now what would be the mass? The mass would be 2250. And if you're wondering where this 2250 came from, that's basically 1500 plus 750. So we've just combined them. Okay, because they're both going to be moving together, so they're moving at the same speed. Into g, which is equal to 10, into h, which is equal to 800 sine theta. And this will overall have a positive value. Why? Because it's going up the plane, therefore there will be an increase in potential energy. Plus the change in kinetic energy. Now you don't have to worry about the sign with change in kinetic energy, that will take care of itself. Why? Here's what you have to do. It's going to be 1 upon 2 into mass, which is 2250, once again 1500 plus 750 into v squared. So that means you're going to do final velocity, which is 20 squared, minus the initial velocity, which is 30 squared. Okay, so you don't have to worry about writing the plus or minus sign with kinetic energy, that will just take care of itself. But just remember to do the initial velocity minus the final velocity. No, there is nothing to do with tension over here. Okay, nothing to do with tension over here. Now, let's see what this brings us. So this would be 800 times F, which is the driving force. Driving force को मैं काम करता हूँ, I'll just call it F. Okay, minus 480,000. Okay, equals to, let's work this out, 2250 multiplied by 10 multiplied by 800. And remember, sine theta is equals to 0.08. So this is equal to 144 and 4 zeros. 1, 2, 3, 4. Yeah, 1,440,000. Now why would it be 30 square minus 20 square? Because it says the car and trailer have speed 30 meters per second at the bottom of the hill and 20 meters per second at the top of the hill. So the final velocity is 20, the initial is 30. Okay, now plus, let's work this out, 0.5 into 2250 into 20 squared minus 30 squared. Okay, so when you work this out, you get minus 562,500. Remember, change in kinetic energy is equal to 1 upon 2 times m times v square minus u square. Simple as that. Now what's the final velocity? The final velocity is 20, that's at the top. What's the initial velocity? That's 30, that's at the bottom. So final minus initial with the square, obviously. Okay, so we're there. All you have to do is work this out. Let's see what we get. So 800F is equal to, so 1,440,000 plus 400 and, okay, so let's work this out again. 1,440,000 minus 562 500 plus 480 1 2 3. So 800F is equal to 61,500. Let me just double check. So 1440123 minus 562 500 plus 480123. No, wait a minute. Sorry, that's incorrect. It's equal to 1,357,500. Okay, so be careful with these calculations. They're very lengthy. Now let's divide this by 800. And when you divide by 800, you get 1696.875. That's the driving force that the question was asking for. So the driving force, you can leave it as it is, or you can round. In fact, it's best to leave it as it is because it's exact. But if you do round off correct to 3 significant figures, it's going to be 1700 newtons. That's it. So what do they mean by my energy method? Does it necessarily... What do they mean by energy method? So there are many ways of writing this equation. Yours may be slightly different. There's another approach where it's initial energy, initial equals to final, or energy at the start equals to energy at the end. You can do it like that. There are many ways of writing down this formula. Okay, but when they say energy method, this is what they mean. That you take the work done and you take the energy in one equation. That's what it means basically. Okay. Now there's a part B. Let's see what part B says. Part B says, after reaching the top of the hill, the system consisting of the car and trailer travels along a straight horizontal level road. Okay, so that means now we don't have to consider the weight component. The driving force of the car's engine is 2400 and the resistance to motion are unchanged. Find the acceleration of the system and the tension in the tow bar. Okay, now we have to find out the tension. So here's what we're going to do. This is the car and this is the trailer. Now what's the resistance to motion of the car? That's 400, I believe. Yeah. And what about the trailer? So this is the car, this is the trailer. For the trailer, it's 200. And what's the driving force? The driving force is 2400 Newton. And I always like to make these arrows, okay, these double arrows, which help me figure out where the object is moving. Okay. Now let's look at things from the perspective of the car. So from the perspective of the car, and don't forget that for the car, the tension is acting in this direction. For the trailer, the tension is acting in this direction. So for the car, the forward force is 2400, and there are two forces acting in the opposite direction. One is T and the other is the 400 Newton resistance force. Okay, the force which is basically resisting the motion. And this is equal to what? This is equal to mass times acceleration. What's the mass of the car? That's 1500. So 1500 A. Let's write this nicely. So this would be 2000 minus T is equals to 1500 A. Let's look at things from the trailer's perspective. From the trailer's perspective, the force that's acting forward in the direction of motion, that's T, and minus 200, and that's equal to mass times acceleration. What's the mass? That's 750. So 750 A. Now when you add them up, T gets eliminated, and you're looking at 1800 is equal to 1500 plus 750, that's 2250. A, and what's A equal to? 1800 divided by answer, and that's equal to 0.8 meter per second square. Okay, you can write it like this, or you can write it like this. Can you do a question from 2019? If it's in this question, in this PDF, there are all questions are from 2020 onwards. So maybe I'll do a separate stream on that, taking questions prior to 20. I would suggest that it's best that you do recent questions. Now, in order to find out tension, you multiply it by 0.8. Okay, let's see what you get. So when you multiply this by 0.8, just solve for the value of T. So 750 into 0.8 plus 200, and the tension is equals to 800 newtons. There you go. Okay, I've already answered that question. That is not in the syllabus. Okay, finding the inverse of a square function is not in the O-level math syllabus. Finding the inverse of an exponential function is also not part of the syllabus. Okay, so I hope that's clear. All right, so that was this part was fairly easy, but this part was quite technical, and let's do a slightly more complex question. Let's do this question. Let's see what this says. Two particles A and B of mass 0.3 and 0.5 kg respectively are attached to the ends of a light inextensible string. The string passes over a smooth fixed pulley. Just a minute. Yeah. The string passes over a smooth fixed pulley which is attached to a horizontal plane and to the top of an inclined plane. Okay, which makes an angle of 30 degrees to the horizontal. The string is taut and can move on a line of greater slope of the inclined plane. Okay. A force of magnitude 3.5 newtons is applied to B acting down the plane. So there is an external force which is pulling it. Here it is. Achha, I don't understand tension direction. Remember, tension is always acting away from the object. So if you're considering the car, tension is acting away from the car. If you're considering the trailer, the tension is acting away from the trailer. That's the rule of tension. Okay, always acts away from the object. Like for example, here, when we're thinking of, when we're resolving from B's perspective, tension is acting in this direction. And when we're resolving from A's perspective, tension is acting in this direction. That's the rule. I appreciate that. Achha. Given that both planes are smooth, find the tension in the string and the acceleration of B. So let's resolve from A's perspective. If I resolve from A's perspective, let's see what that looks like. Because it's smooth, that means there's only tension that's acting towards the right. There is no friction force. So T minus 0 is simply equal to 0.3. That's it. Nothing to worry about. But when we resolve from B's perspective, so for B's perspective, we have to be a little bit careful. Because B is on an inclined plane, so it's best that we consider its weight components. Weight components parallel to the plane, weight component perpendicular to the plane. So this will be 5, this will be 30, this will be 5 sine 30. Okay, and there will be a component which is acting perpendicular to the plane. That's the normal reaction force. Here it is. And don't forget, tension is acting in this direction. So what are all the forces? And also, I like to make these arrows. These arrows help us deciding where the object is moving, and that's the force that we consider as the forward force. All forces acting in this direction will be considered as the forward force. So notice that there are two forces that are acting in the direction of motion. One is 3.5, the other is 5 sine 30. Okay, and what are the forces that are acting in the opposite direction? Because it's a smooth plane, we don't have to consider friction, and tension is acting in the opposite direction. And what's this equal to? This is equal to 0.5a. Okay, now let's simplify this. Let's see what we get. So this is going to be 2.5 plus 3.5, that's equal to, what's that equal to? That's equal to 6, yeah. So 6 minus t is equals to 0.5a, then t minus 0 is equals to 0.3a. Let's add them up. T gets eliminated. So 6 is equals to 0.8a. Now you can find out acceleration. Let's see what that's equal to. 6 divided by 0.8, that's equal to 7.5 meter per second square. There you go. Okay, now let's see what's next. Next, the question says find the tension in the string. Okay, so how do we find tension in the string? You can use any simpler of the two equations. T is equals to 0.3a. Plug in the value of a here. So T would be equal to 2.25 Newton. And that's it. 5 easy marks. Okay. But now, the question that we're about to solve, that is the tricky part. Okay. It is given instead that the two planes are rough. When each particle has moved a distance of 0.6 meters from rest, the total amount of work done against friction is 1.1 joules. Use an energy method to find the speed of B when it has moved a distance, when it has moved this distance down the plane. Okay. Which distance? 0.6 meters. You should assume that the string is sufficiently long. Okay, that's something that we assume, that it doesn't reach the pulley. Achha, a good idea would be to use this rough sketch that I've drawn above. Okay, so I've just taken a screenshot to make things easy. Now, energy method means, this is what energy method means, that total work done is equals to change in potential energy plus the change in kinetic energy. Okay, now the two planes are rough. Keep that in mind. That means we have to consider friction. And the good news is that we're already given the work done against friction. That's 1.1 joules. Okay, now, is there a driving force? Yes, there is. The driving force is this external force, which is 3.5 newtons. So when we break down total work done, the work done by the driving force, the force will be 3.5 newtons. So 3.5 minus 3.5 multiplied by the distance that it moves. What's the distance? That's 0.6. Okay, so B moves from here to here, which is a distance of 0.6 meters. Okay, Acha. Also, a good idea would be to find out the height. So in order to find out the height, we're going to draw a separate triangle. Here it is. This is 0.6. The angle is 30 degrees. So the height is equal to 0.6 sine 30. Okay. Now, so 3.5 times 0.6, that's the work done by the driving force. Okay. Work done against the driving force, that's already given. That's 1.1. Okay, given in the question. Is equal to change in potential energy. Now, when you're calculating change in potential energy, remember it's going to be negative. Why? Because it's going down the plane. So minus times 0.5 times 10 times the height, which is 0.6 sine 30. Now, as far as the change in kinetic energy is concerned, that takes care of itself, whether it's increase or decrease. You just have to use the relevant formula. So half into 0. Achha, also do keep one thing in mind, that as far as A is concerned, there is no change in potential energy of A because it's moving on a horizontal plane. Okay, so that's why I noticed that the mass that I've considered is of B only. Okay, mass of B only. But when we are talking about kinetic energy, so because both these objects are moving, that means both of them will possess kinetic energy. So the mass that we will take will be of A and B combined. So it's going to be 0.8. So this 0.8 is basically the mass of A and B combined. क्योंकि दोनों हिल रहे हैं, दोनों move कर रहे हैं, so दोनों के पास kinetic energy है. Okay, और दोनों के पास equal kinetic energy है because they're connected, they're moving at the same speed. So into V square. Or you can think of it this way, V square minus 0 square, because the initial velocity was 0. Okay, now let's work this out. 3.5 times 0.6, that's equal to 2.1. 2.1 minus 1.1, that's equal to 1. So 1 is equals to 0.5 into 10 into 0.6 sine 30, that's equal to 3 upon 2 or minus 1.5. So minus 1.5, let's write this nicely. Plus 0.4 V square. So shouldn't we also include T into 0.6 as work done by A? Okay, why would you do that? Just a minute, let's work this out. So 1 plus 1.5, that's equal to 2.5. 2.5 is equal to 0.4 V square. V square is equals to 2.5 divided by 0.4, that's 6.25. And then let's take the square root. So if you take the square root of the answer, we get the correct answer, which is 2.5. 2.5 meters per second. There you go. Dekho, Akmal, you have asked a good question. Basically, if we take that into consideration, and then if we consider it for B also, they will both cancel out each other. Okay, if let's say, for example, you do T into 0.6, for A, for B, you will do it with the opposite sign, and they will cancel out each other. Okay, so that's why we don't take that into consideration. Okay, so I hope that answers your question. We take that into consideration when one object is perhaps moving a separate distance compared to the other. Okay, maybe when we will do a question, in fact, when one object is moving vertically and the other object is moving horizontally, that is when we take that into consideration. Okay, here they're both moving the same distance, so we don't take that into consideration. But that was a good question. Good thing that you pointed out. But anyway, here's the answer. So I'll quickly summarize it for you guys. So total work done means by minus against is equals to change in potential energy plus change in kinetic energy. Change in potential energy will be negative because it's gone down. And the change in kinetic energy, well, we just take it as it is. It takes care of itself. Why do we take A and B mass combined? The reason why we don't consider the change in potential energy of A is because it's horizontal. So there is no change in height. So the change in potential energy is equals to 0. But as far as kinetic energy is concerned, so remember, A and B are both moving. Okay, so A and B are both moving. That means they both have kinetic energy. And they will both have the same kinetic energy because they're both moving at the same velocity or the same speed. Okay, let's do another question. Maybe let's do this question. Yeah, let's see what this question says. Which O-level topic will be covered next? Tomorrow, inshallah, I'm streaming frustum. Okay, tomorrow I'm doing a stream on mensuration. I'm covering frustum. Okay, let's solve this question. Let's see what this says. So where to access these type of worksheets for other M1 topics? You can download them from the website, although they will be slightly different. But every stream that I do, I will share the worksheet and you can download it from the link in description. So it's total work done by engine minus total. Yes, total work done by driving force. Okay, and normally driving force engine se hi aati hai. Okay, or any force, any external force, any pulling force, that could be any driving force or any external force that's acting in the object, in the direction the object is moving. Now, two particles P and Q of masses 0.5 and m kg respectively are attached to ends of a light inextensible string. The string passes over a fixed smooth pulley which is attached to the top of two inclined planes. The particles are initially at rest with P on a smooth plane inclined at an angle of 30 degrees. So let's underline that. P is on a smooth plane. Okay. The string is taut and the particles can move on lines of greater slopes. A greater slope of the two planes, a force of magnitude 0.8 newtons is applied to P acting down the plane, causing P to move down the plane. So that means this is the direction in which the whole system is moving. Okay, so I like to make these arrows. It just makes it easier to consider the forward force and the backward force. Now, okay, now let's talk about P. Now let's break down the forces because we have to consider the weight component as well. So here we are. This is the weight component acting down the plane, and this is the component which is acting parallel to the plane. There you go. Now the weight component is 5 newtons. Okay, this would be 5 sine 30. And don't forget that there will be a normal reaction force, although we may not have to consider it because it's a smooth plane. As far as tension is considered, tension is acting away from the object. Now let's talk about M. So we're given M is 0.3. Okay, so that means this will be 3 newtons acting down the plane. This is a 90-degree angle. This will be 3 sine 45. And this is the normal reaction force, which we don't have to consider because it's smooth. And don't forget, tension is acting in this direction. Okay? Now, let's find out the tension in this string. So let's start resolving. Let's first resolve from P's perspective. So from P's perspective, this is the force that's acting in the direction the object is moving, and this is also the force that's acting in the direction it's moving. So that means these two forces become the forward force. So we have 0.8 plus 5 sine 30. Okay, now what's the force acting in the opposite direction? That's T. Is equal to 0.5a. Now let's simplify this a little. 5 sine 30 is 2.5. 2.5 plus 0.8 is 3.3. So 3.3 minus t is equals to 0.5a. Now, let's resolve forces from Q's perspective. From Q's perspective, so Q has mass m, not 3. Better read the question, Akmal. For the first part, you're given that m is equals to 0.3. Okay? Now, let's resolve forces from Q's perspective. So Q is moving up the plane, so that means for Q, tension is the forward force, and the force that's acting in the opposite direction is 3 sine 45. Okay? And what's that equal to? That's equal to 0.3a. Now, as we add the two, t gets eliminated. Okay? And here's what we have. 3.3 minus 3 sine 45. That's equal to 1.17867. It's not the final answer, so we're not rounding off. Is equals to 0.8a. Okay? That's next. Let's find out a. Let's divide by 0.8. So a turns out to be 1.4733. 1.4733, which correct to three significant figures will be 1.47 meter per second square. Now, so the question did not ask us to find out the acceleration. Okay. The question actually asked us to find out the tension. So, koi baat nahi. 3.3 minus t is equals to 0.5a. So, 3.3 minus 0.5 into 1.4733 dot dot. The answer key is equals to t. So, let's work this out. 3.3 minus 0.5 multiplied by the answer. So we get tension to be equal to 2.56 newtons. Tension is equals to 2.56 newtons. There you go. Yep, that's correct. Okay, now let's do part B. Part B says it is given instead that the plane on which Q rests is rough. Okay. So first of all, let's have a look here. This is the same plane. And that after each particle has moved a distance of 1 meter. So that means this moves a distance of 1 meter. And this will also move a distance of 1 meter. So this is P prime and this is Q prime. Okay. So what happens after that? Their speed is 0.6 meters per second. All right. The work done against friction in this part of the motion is 0.5 joules. Use an energy method to find M. Energy method means, once again, total work done is equals to change in potential energy plus the change in kinetic energy. Now, this is a complicated question because you have to consider both the particles. So first of all, let's calculate the change in height for P. Okay, so we can work that out like this. The change in height for P would be equal to, so because the distance that it moves is 1 meters and that 1 meter is here, by the way. This is 1 meter. Yeah, kaam karte hain. My advice would be, I'm just going against my own advice. My advice is always that you draw it separately. So this is what things look like for P. This is 1 meter. This is 30 degrees. So that means height would be equal to 1 sine 30. Okay, then as far as Q is concerned, so this was for P. Okay, the change in height for P. As far as Q is concerned, the change in height for Q looks like this. It moves 1 meter up the plane. This is 45. So the height is equals to 1 sine 45. Okay, now let's start putting things together. Okay, so what's the driving force? Driving force is any external force. Okay, and that is the 0.8 newtons. Okay, so 0.8 multiplied by the distance, which is equal to 1. And what's the work done against friction that's given to us in the question? That's 0.5. Okay. Is equal to change in potential energy. Now, as far as P is considered, P loses potential energy. As far as Q is considered, Q gains potential energy. Now, what would be the loss in potential energy for P? That would be 0.5 times 10 times 1 sine 30, or simply sine 30. Okay. Acha. Plus, what is the change in potential energy for Q? So this was for P. Now, what's the change in potential energy for Q? That would be 0. Actually, that would be M. Okay, so M into 10 into sine 45, because that's the height that it gains. And this will be positive. Why? Because it gains potential energy as it's moving up. Now, as far as the kinetic energy is concerned, because they're both moving at the same speed, so we don't have to break down the change in potential. We don't have to break down the change in energy, just like we did for potential energy. Why are we considering the change in potential energy for P and Q separately? That's because there is a separate change in height for P, there is a separate change in height for Q. Okay. Now, because they're both. So if, let's say, we had a car and a trailer. Okay, if we had something like this, that this was the plane and this was the car, this was the trailer, then the change in potential energy would be the same for both. But because one is here and one is here, so the change in potential energy is different for both. Okay, now what about the change in kinetic energy? Change in kinetic energy will be the same for both because they're connected and they will have a common speed. So the combined mass would be m into 0.5 into the speed, which is 0.6 squared. Okay, that's given to us. 0.6 squared in the question. Okay, so I hope that's clear. Let's go over it one more time. Work done by the driving force minus work done against friction. Change in potential energy of P, because P goes down, therefore it's minus, plus change in potential energy of Q, Q goes up, therefore it's plus the change in kinetic energy. Now, why are we taking their combined mass? Because they're both connected and therefore moving at the same speed. Okay, so 0.8 minus 0.5 is equals to 0.3. And why are we not considering the work done by tension? Because they will cancel out each other. So if you were to consider the work done by tension for P, that would be T into 1, okay, on one side. And then if you were to consider the work done by tension for Q, that would be T into 1 on the other side, and they will cancel out each other. So 0.3 is equal to, let's see, what do we have here? Minus 0.5 into 10 into sine 30. So that's minus 2.5 plus, so 10 into sine 45, that's 5 under root 2m, plus 0.6 squared is 0.36, divide by 2, that's 0.18 into m plus 0.5. Okay, so we're almost there. Let's start adding this up. This is 2.8 is equals to 5 under root 2m plus 0.18 m. And what's 0.18 multiplied by 0.5? That's 0.09. So 2.8 minus 0.09 would be m minus 0.5. It's plus. It's not minus, it's plus. So 2.8 minus 0.09, that's 2.71. Let's take m common here. So that would be 5 under root 2 plus 0.18. Now finally, let's make m the subject. That would be 2.71 divided by 5 under root 2 plus 0.18. And that's it. This is it, the moment of truth. 2.71 divided by 5 under root 2 plus 0.18. What do we get? We get 0.3737, which correct to 3 significant figures is equals to 0.374. And that is the correct answer. ठीक है, मज़ा आया? Good question, right? Acha, what's the time? I have time, so maybe let's do one more question. Okay. October, November 2024, question number 5. Let me see if I have October. Is it in this PDF? If it's in this PDF, I'll do it. If not, then I'm afraid not. अच्छा, let me do a slightly, because it's मेरी class का time हो गया, so let me do a slightly simpler question, and then I'll do a part 2 of this. I think on Sunday I'll do a part 2 of this. क्या ख्याल है? There was this one tricky question back in 2020. I hope, yeah, here it is. So I'll solve this question, and then I'll do a part 2 of this stream, inshallah, in the coming week. Okay. So it says a child of mass 35 kg is swinging on a rope. The child is modeled as a particle and the rope is modeled as a light, inextensible string of length 4 meters. Initially, P is held at an angle of 45 degrees to the horizontal. Okay. Given that there is no resistance force, find the speed of P when it has traveled halfway along the circular arc from its initial position to its lowest point. So that means halfway would be something like this. And because it's halfway, that means the angle would be 22.5 each. Okay. Now, what do we have to do? We have to calculate. Find the speed. Now, because there is no resistance force and because there is no external driving force, okay, there is no pushing force, there is no pulling force. So what does that mean? That means the change in potential energy would be equal to the change in kinetic energy. Okay, so if you use this formula, total work done is equals to change in potential energy plus the change in kinetic energy. So because there is no total work done, so that means the change in potential energy, the loss in potential energy would be equal to the change in kinetic energy, the gain in kinetic energy. Okay. Now, where is the object right now? This is where the object is right now. Okay. Now, when it travels here, this is where it's going to be. Also, don't forget that this is kind of like a sector. So that means this is equal to 4. Okay. And what about the height? So this height would be equal to, so if you look at this triangle, this is a right isosceles triangle. Okay, this is 45. So that means this would be equal to 4 sine 45 or 4 cos 45. Doesn't matter whether it's sine or cos, actually. 4 cos 45. Okay. Now, what about the entire height? As in, what about the height from here to here? So this height, now what's this angle going to be? In fact, we already have this angle, 22.5. So that means this length in green would be equal to 4 because the hypotenuse would be 4 cos 22.5. Okay, so I'll draw them separately so that you can make more sense. So initially, this is what the height is. This is P, this is 4, this is 45. So that means this would be 4 cos 45. Okay. Now, as it moves down, the height decreases. Okay. And this is where it is. P prime. And this is 22.5. And this is still 4. So this now becomes 4 cos 22.5. Okay. Now, what is the loss in potential energy? The loss in potential energy would be this. mgh, what's the mass? That's 35. So 35 times 10 times the height. Okay, now what would be the height? The final height is 4 cos 22.5 minus the initial height, which would be 4 cos 45. Okay, so this is the loss in potential energy. And this is equal to what? This is equal to the gain in kinetic energy. So that means this is equal to half into 35 multiplied by V square. Okay, so loss in PE is equals to gain in KE. Now, even if this turns out to be negative, make sure that you take it as positive only. So 35 times 10 times 4 cos 22.5 minus 4 cos 45. So this is 303.481 something is equals to 35 upon 2, which is going to be 17.5 v square. So divided by 17.5, take the square root of the answer, and we have 4.16. 4.16 meters per second. Let's see if that's the correct answer. I think it is, but just to be on the safe side. Yes, it is. Okay, now let's have a look at part B. Part B says it is given that there is a resistance force. Okay. The work done against resistance force as P travels from its initial position to its lowest point, it's x joules. The speed of P at its lowest point is 4 meters per second. Okay. What are we supposed to calculate? We're supposed to calculate x. Now, once again, we're going to use the same equation. Total work done is equals to change in potential energy plus the change in kinetic energy. Okay. Now, and what are we supposed to do? We're supposed to calculate the speed of P at its lowest point is 4 meters per second. So that means from here to here. So the change in height would be 4 minus 4 cos 45. So this is what it looks like now. So here the height was 4 cos 45. Now it's 4. Okay. Now total work done means by minus against. Now there is no driving force, but there is a resistive force, which is x, equals to change in potential energy, which would be 35 into 10 into 4 cos 45 minus 4. Actually, 4 minus 4 cos 45. Because this is where it was and this is where it is now. So 4 minus 4 cos 45. And this would be negative. Okay. Now, plus 1 upon 2 into the mass, which is 35 into 4 squared, because that's what the velocity is. Now let's work this out. Minus x is equals to, let's see what this turns out to be, minus 35 into 10. (35 times 10 times bracket 4 minus 4 cos 45, close the bracket. So this is 410 plus minus 410 plus, let's see what this is, 0.5 times 35 times 16, that's equal to 280. Achha, now this was actually, just a minute, 35 times 10 times 4 minus 4 cos 45, 410.05 something, 410.05. So let's see what is x equal to, minus 410.05 plus 280, that's equal to 130.05, which correct to 3 significant figures is equal to 130 joules. That's it. Okay. So we're going to keep it till here only. I will do a part 2 of this where I will solve some more complex questions. So I will encourage you guys to download this PDF, solve as many questions as you can, and inshallah in the next class I will be doing some more questions, and I'll also include the February-March question also. So I've included some recent questions, and I'll also include the February-March question. So will you conduct a S1 past paper marathon? Yeah, for S1 I will be, so I've already done a stream on probability. I've done a stream on, I will be inshallah doing a stream on permutations and combinations very soon, but I'm not too worried about S1 because S1 is I think on the 16th or the 14th, I don't remember exactly, but there's time for S1. So I will be doing regular streams inshallah on S1 also. Okay, but right now I'll be focusing on M1 and P1. So I'll stop here. Tomorrow inshallah at 3:30 p.m. I'm streaming P1 functions, so make sure to tune into that if you're struggling with functions. But that's it for today. See you in the next class. Take care everyone. Allah Hafiz.